So y is 2 times, the y value is negative root 3 over 2. And then the 2's are going to cancel. So you get negative root 3. You write your answer as an ordered pair. That's what it'll be looking for on your test.
Yep.
Okay? So let's do... So you see on number 2, the radius is negative. It's going to work out either way. When I taught it during second period, or first period rather, I made this positive, and when I make that radius value positive, what do I have to do?
Add pi.
Add pi. It'll work out either way. The reason I taught it that way is because you guys have had to do that over the last couple of sections, and it'll just help make more sense in your brain. But you could do it either way. You could leave it negative or make it positive. I'm going to make it positive because I think it's more like what you have to do in other places. So I make positive 6, and I'm going to add 4 pi over 4. What do I get? 7 pi over 4. And then I'm going to use not that order pair, but this order pair when I plug it in. Seven pi over 4, what is the x value? Root 2 over 2. I personally like to cross cancel. I find it easier. 2 divides into 6 3 times. So I get 3 root 2 when I do that. The y value is very similar, right? Because it's just root 2 over 2 and negative root 2 over 2. So we do 6 times negative root 2 over 2. Same thing. 2 divides in 6 3 times. So your answer is just negative 3 root 2. Let's do number 4. So we have negative 5 pi over 6. So what radian value am I going to use? 7 pi over 6. Are we good with that? Right, so you get a 5 pi over 6 straight down is negative 5 pi over 6. Right, so 5 pi over 6 is in quadrant 2. I just draw a line straight down to 7 pi over 6. So I'm not going to use negative. I'm going to use 7 pi over 6. So what did we just do to, well, never mind. That's fine. 7 pi over 6. So we're going to go x equals 7 times negative root 3 over 2. And you'll get weird ones like this. That's a times right there. So negative 7 root 3 over 2. There's no guarantee stuff's going to cancel or anything like that. And then next one is negative 1/2. So we get negative 7 over 2. As an ordered pair, I'll just write it up here. Okay. So you're going to get a lower grade, huh, Liam? So sad. He can't even hear me either. He's so into his phone he can't hear me. Your grade just went down 1%. It's so sad. You should put your phone up so it doesn't go down another %. That'd be smart.
I got 100%.
That's good.
Doing great.
You may need it. Okay. So next one we're going to do is number 5. You need your calculator to be in what? Radians or degrees? Degrees. Okay. So if you took 140 and change it into radians to see if that was on the unit circle, it's not. And you can also look at your degrees. So 140 is in between 2 radian measures on your unit circle. So we actually got to use the calculator to figure this sucker out. So x is going to be 9 times, we're going to do cosine 140. I'm just going to write it up here so you know where it came from. And when I do cosine 140, you should play along and do it in your calculator so you make sure you get this answer. Negative 0.7660. When you do sine and cosine, tangent, all that stuff, you want to take it to 4 decimal places. And then our value is negative 6.89. Same thing for y, except sine instead of cosine. Sine 140. And you get 0.6428. And when you multiply those two, you get 5.79. So order of pair is negative 6.89, comma, 5.79. So you won't always get like side lengths from the unit circle, radian measures from the unit circle. Sometimes you get random answers like that. 6 is the same way. We're not going to do it, but same kind of thing. Pi over 15. So if you do cosine of pi over 15, you need your calculator in radians, right? So you're going to have to switch back and forth between degrees and radians on this test on your calculator. It's 100% the kind of thing, if I were in my own pre-calc class, I would have forgotten to do. So, but I would have like written notes on my test, like, hey, dumbass, don't forget to switch back and forth, because you might have to do that. So if that kind of rationale works for you, then write that. Now we're going the other way. We're going rectangular to polar, right? Rectangular to polar right there. And you've got those two formulas up there, so write those down real quick. I think so. I'm pretty sure they're on the sheet. I originally didn't have them on the sheet, and then Mrs. Hine. Anybody have Hine before she retired? Ms. Hine? Didn't you love her? She's the best, right? Yeah, she's awesome. I take no offense, but it's okay. All right, so first thing we're going to do is, so realize that this is rectangular, x and y, and this is polar, where it's a radius in theta, okay? So theta begins with a t. Always the order pairs are in alphabetical order, so radius and theta, if you forget which is which, right? Our t for theta. So we got to plug into our formula here for the radius. So we're going to say r equals square root of 2 squared plus 2 root 3 squared, like that. So when I have that 2 root 3, I always square both parts. And sometimes we'll need to, like on number 8, we'll need to square all 3 parts to that, right? So 2 squared is 4, square root of 3 squared is 3, 4 times 3 is 12, 2 squared is 4, 4 plus 12 is 16. So what's your r equal? 4. Do I need plus or minus? Radius is always positive, so we'll just go with plus. But realize right up here, we need 2 possible solutions. So we're going to do the plus radius first, and then we'll deal with the minus radius one next. Okay, so this is where it gets confusing. So next we're going to do the theta, right? So theta is inverse tan of y over x. So the y value is 2 root 3, the x value is 2. So draw a little dividing line here. So our theta is going to equal inverse tan of y 2 root 3 over 2. What happens with the 2's? So we have inverse tan of root 3, right? Just canceling those 2. So when I do inverse tan, what am I getting? A side length or radian measure? Inverse sine, cosine, and tan, I always get angle measure. If you forget that, write that down again, right? The inverse give you an angle measure. The regular ones give you a side length, right? And you can think about it just with right triangle trig. Like that's how it works, right? If we do inverse sine, cosine, or tan, we always get an angle measure. We do regular sine, cosine, or tan, we're figuring out the side length on a right triangle. It's like the most valuable math strategy you can have is like relating it to something you get and just applying that logic to more difficult concept. It will really, really help you out. So where is tangent square root of 3? At what radian measure? Pi over 3. Where else? 4 pi over 3. So we get two answers here, pi over 3 and 4 pi over 3. So we know we're going to have a positive and a negative radian measure. So we have to figure out which one goes with which. Which one is a positive? Do we use pi over 3 or 4 pi over 3? Here's how you figure it out. So when I look at this coordinate, they're both positive. Where are x and y both positive? What quadrant? Quadrant 1. Okay? So my positive 4 is going to go with the radian measure in quadrant 1. Okay? So our positive 4 goes with which? 4 pi over 3 or pi over 3? Pi over 3. So what's a negative 1? So if I do negative 4, then I have 4 pi over 3. Okay, so you got to think about the quadrant up here, right? Because that'll help you figure out which one goes with the negative and which one goes with the positive. All right, let's do number 8. So r equals that big S thing squared. Okay. So I square all three parts. So I'm squaring the 3, the root 2, and the 2 in the bottom. 3 times 3 is 9. Square root of 2 times square root of 2 is 2. 9 times 2 is 18. And then the 2 squared in the bottom. So I have 18 over 4, which reduces to what? 9 over 2. So I'm going to erase that and just write 9 over 2. So I don't have to write like 8,000 steps. So 9 over 2 plus 9 over 2. What's 9 halves plus 9 halves? That's confusing, right? Think about it again, making an easy concept you can get. It is, yes. But if you think what's 1 half plus 1 half, what do you get? 1. So 9 halves plus 9 halves is 9. Makes it easier to think about it like that, right? So really, you know what a half plus a half is. It makes a whole. So 9 halves plus 9 halves has got to make 9. Okay? You can just think 4.5 plus 4.5 as well, right? If you didn't get that. Like either way, doesn't matter. You can still get the right answer. So this equals 9. Square root of 9 is 3. Okay? What quadrant am I in up top? So positive x, negative y. Quadrant 4. You can do that right away. I just forgot about it. That's why I didn't write it right away. So we get positive 3. Now we got to do the inverse tan stuff. So I'm going to do copy dot flip right away because I don't want to write a quadruple Decker fraction because it'll make me sad. So we're going to go 3 root 2 over 2 times, and I'm going to flip the other one, negative 2 over 3 root 2. So what do I get? Negative 1. So where is inverse tan? At what radian measure is tangent equal to negative 1? Or I shouldn't write it like that. I should write it like this. So at 7 pi over 4 and what?
3 pi over 4.
So 7 pi over 4 and 3 pi over 4.
Yeah.
So do you see a pattern of getting that other radian measure? Looking at your unit circle? 7 pi over 4 and 3 pi over 4 are right across from one another, right? So you can always do that. So remember when we did the radius thing and we're adding pi to get the other one? That's the same concept, right? So it's just directly across on the unit circle. So what's our first correct order pair? 3 comma what? 7 pi over 4. And what's the other one? Negative 3 comma 3 pi over 4. Okay. All right, let's get to some weird ones. That's okay. I want to get one of these. Okay, let's do number 11. So what quadrant are we in? First question. Positive x, negative y. 4 again. That's funny because I wrote it in the wrong quadrant in my notes. That's why I was looking at it weird. So r equals square root 6 squared plus negative 4 squared. So 36 plus 16, 52. So 52 we can break apart. What's the biggest factor of 52 you can square root? 4 and 13. So when we do that, we get 2 root 13. Super fun.
Why do you want to break it apart?
You just always have to simplify square roots. Every single time you see them, if you can simplify, you got to simplify. Just a annoying math rule, essentially. So we're going to do inverse tan. Make sure your calculator's in degrees when you do this one. So you have negative 4 over 6. You could put that, because that equals negative 2 over 3. Doesn't really matter. You don't have to reduce it in your calculator. When you do inverse tan of negative 2 over 3, what do you get? Let's do it on here so we can see. Make sure you're in degrees. So second tan of negative 2 divided by 3. Oops, I did 2 of them. So is that on the unit circle? So now what do I have to do? Do I add 180 or do I add 360? Because I want my angle measure to be where negative 33 is. So you got to add the 360 to go all the way back around to get the positive. So I just go plus 360 right there, and I get 326.3. So that equals negative 33 plus 360 was something, 326.3. Okay, so is 326.3 in quadrant 4? Yes. So my first order pair, I'm going to write it by 12, is 2 root 13, comma, 326.3. If I make my 2 root 13 negative 2 root 13, what do I do from 326? Add or subtract 180? Subtract 180. So in your calculator, you can just leave that in there and just go minus 180. And then you get 146.3. Those are your positive and negative answers. Okay? So there's a lot of little aspects to it, but that's it. You're doing 1 through 8 all? Get her done. 1 through 8.